Okay, this is lesson 5.5, page 244 in your book. Today we're going to be talking about slope. And slope is a number that describes how steep a line is. And mathematically, that basically is the formula. Slope is equal to the vertical change between 2 points divided by the horizontal change of those 2 points. And an easy way to remember it, and I use it all the time, is rise over run. And you'll see why here in a little bit. First thing we look at is, let's take an example. If we had line AB here in this first example, we wanted to know what the slope of that line is. Well, we're going to come over here and use the rise over run method. So what is the rise? Well, we start at point A. If we start at point A and go to point B, and I usually say just use the left point first and then the right point, and whether or not it's up or down, just use left to right. And we want to know the rise. Well, the rise here is this 8 units. If we go look at that, we can see that if we count the units, 1, 2, 3, 4, 5, 6, 7, 8. We went up 8 units to get there. And I'll do it over here on this side so you can see it. That the blue line was actually 8 units. Now, that's our rise. So our rise got to be this number 8 right here. Well, we have to put it over the run. So our bottom number is going to be the run. So let's take a look at it. The run is from A to B, 1, 2, 3, 4, 5, 6. In other words, straight across. Don't go up or down or any angle, just straight across. There was 6 units there. So this is our 6 down here. And then if I have 8 over 6 as a fraction, I can reduce it to 4 over 3. And that basically means for every 4 units that you rise, you must run 3 units. So let's just take a quick look. Let's do it in a different color. Let's do it this light color. If we came over 1, there we go. Now we got it. If we came over 1, 2, 3, 4 for our run. So, excuse me, run is the bottom number. It is just a 3. Run is the bottom number. So let's get everything back. Get right to the color. Run. 1, 1, 1, 2, 3, up, 1, 2, 3, 4, and over 1, 2, 3, and up 1, 2, 3, 4. And you can see that our slope of 8 over 6 is the same as 2 times doing 4 over 3. All right, let's look at the second one, the one here on the right. Oh, by the way, that ends up with a positive number, right? So that's a positive slope. And I'll explain that a little bit more, but basically from left to right, you're slanting upwards. Now let's take a look at example B here, the one that's labeled negative slope. From point C to point D, we need to figure our rise and our run. Well, our rise, in this case, if we look at from C down to D, we go 1, 2, 3. But instead of going rise up, we went down. Thus, we give it a negative 3 for our rise. And then our run is 1, 2, 3, 4, 5, 6. And that gives us our 2 numbers of negative 3 over 6. And you can reduce that to negative 1 over 2. So negative 1 over 2 is just basically telling us, let's do this in, let's pick that purple color again. We're going to go down for every rise of negative 1, we're going to go over 2. Negative 1 over 2, negative 1 over 2. And you can see that we could step it out at the negative 1/2. All right, so now one last thing on negative slope versus positive slope. The real concept here is just left to right. If you're slanting upwards, it's a positive slope. And if you're left to right slanting down, it's negative slope. Sometimes I do describe this as having a car And if my car is going uphill, left to right, that's a positive slope. If my car is going downhill, then that's a negative slope. Two more kinds of slope out there. What happens if we had this example here where E to F, the line E to F here, E to F, is straight up and down? Well, if we go rise, it's very simple. One, okay, that's where we started. So 1, 2, 3, 4, 5. So our rise is 5. And we got that right here, a rise of 5. But our run, if we look at our run here, there is no run. It doesn't go anywhere. Okay, it stays exactly the same. So the run is 0. And if we put that into our fraction, 5 over 0 is something you can't do. It's actually undefined. And so this slope of EF is actually undefined. And if you go to the car analogy, if I had my car here and I was trying to drive it, I'd be running into a cliff, and I can't drive up a cliff. Can't drive up a cliff. So that vertical line represents the cliff, and I can't go up it. So if I'm using my car thought pattern, the driving up a cliff is undefined. Now let's go over to the last type of slope there is, and that's the zero slope. And that just is kind of the opposite of the undefined slope. It's a horizontal line. So in this case, we're going from G to H, where our rise is 0. The rise here is not going anywhere. So we got a 0, and that's it right here, the rise over the run. And the run is 6 units. 1, 2, 3, 4, 5, 6 units. So we've got our rise over our run, and that's a valid number. It's just 0. 0 over any number other than 0 is 0. So if you want to say that, you can say, use your car analogy again. Well, it's not going uphill, and it's not going downhill, and it's not running into a cliff, so the slope is 0. Car's just running along the flat plane. All right. Okay, now let's talk about parallel and perpendicular lines. We have two lines with an equal slope are parallel. So their slope has to be the same once we figure out their rise over the run. If they're the same, then we have parallel lines. Two lines whose slopes have a product of -1 are perpendicular. And what is a product of -1? Let's just take a look. Let's say I have a slope of 3 over 2. I multiply it, product, times the negative reciprocal of it, -2 over 3, and I get -1. Thus, these two lines, the line with the slope of 3 over 2 and the line with the slope of -2 over 3, both are multiplied together, give us -1. Thus, we have a perpendicular line. A lot of times I just refer to this as if the slopes have an opposite sign and are reciprocals, then it's a perpendicular line. So let's take a look at an example here. We have this series of lines in this table, and they tell us what the slope of each line is. So we know that for a parallel line, if we're trying to figure out a parallel line, we must have equal slopes. So if I look at this, I see that I have a 4/3 here and another 4/3, and nothing else has a match. So I can say that line PQ is parallel, and that's the symbol for parallel, two lines straight up and down, to line AB. All right, so let's see if we have any perpendicular lines. Perpendicular would mean that the slope has to be reciprocal first. So I see 5, 4, and 4 over 5. So that's the candidate. Then I got to say, do they have opposite signs? Well, this is a positive sign here. There's nothing there. It's positive. This is a negative. So those two are perpendicular. So I can now say that line RS is perpendicular. And that's the symbol for perpendicular, the kind of upside down T with a GH. And make sure I put my line bar at the top. And those two are perpendicular. And nothing else actually ends up being perpendicular. Kind of tried to fool you with this one here because they say the slope of PA is -1, but that doesn't bother us. It has to be this, for it to be perpendicular, it's not that its slope is -1, it's that the product of the slope is -1. All right, now we got 4 examples. We're just going to do them. Let's start off with graphing the points. We have to graph the points, and then we have to name the quadrilaterals in them. Okay? And to do so, we have to know which lines are parallel and which lines are perpendicular after we draw the lines. Okay, so let's start off with point J, -5, 3. So -5 takes me all the way over to this section, and 3 gives me up 3, so there's my first point, J. Then I take point K, which is -1, which is right there, and up 3, and there's point K. Now I'm going to look at point L, which is -1, -1, right there. There's point L. And finally, -5, -1 is point M. I then put the points together in the graph. Let's do that one better. There we go. Let's do these two a little better. And there we go. Now we look at our 4 points again. I'll make them a different color so we can see them. All right, now we got to figure out the slopes. Well, right away on this one, I can see that I have 2 vertical lines here. And if I remember my car analogy, vertical lines are cliffs. So my slope here is undefined. And my slope over here is undefined. And then if I took a look at my 2 flat lines, if I remember correctly, in my flat lines, the slope is 0. So there's 0 here and a 0 here. So I know that I have 4 even lines. They're all 4 units long. I know that the left and the right side are perpendicular, and the top 2 sides are parallel, and the top and bottom is parallel, and left and right is parallel. And then if I take a look at them, I know that those 2 lines all form a perfect square. Those are right angles. And so after looking at this, I say that this guy is a square. He's also a rectangle. It's also a parallelogram. And he's also a rhombus. And finally, it's a quadrilateral. Okay. Now let's do the next one. Let's map out our points. -1, 2 is right there, and that's W. Then 5, -2. Oops, let's draw that back. 5, -2 is right there. 3, -5 is right here. Let's see, this is W, this is X, this is Y, and then Z is -3, -1. And if we draw these guys out, we have to see if they're parallel. And we're going to do that by looking at the slopes. So the slope of rise over run for ZW, well, the rise is 1, 2, 3. So we know we're going to have a 3 on the top. And the run is 1. So the slope of this line is 3 over 1, or 3. Let's take a look at X and y, the rise for x and y is 1, 2, 3, and the run is 1, 2. I think I miswrote this, but let's go ahead with it as is. I think in your book the example actually has the slightly different drawing. So we're going to get 3 over 2. So we know that xy and zw are not parallel because they have different slopes. This slope here is 3 over 2, and this one over here is 3. Now let's take the slope of wx. Let's take a look at wx, and then we'll also take a look at the slope of zy. Well, the rise from w to x is a negative 1, 2, 3, 4. Negative 4 over, well, what's my run? My run is 1, 2, 3, 4, 5, 6. So that gives me a negative 2/3. So I'll write that here. And zy, my rise is 1, 2, 3, 4, but it's negative. And my run is 1, 2, 3, 4, 5. Yep, I definitely did this example different than the example in the book because this one should have came out to be parallel, but it isn't. And then this, you can't reduce 4 over 5. Let me write that a little better. 4 over 5. And so none of these items are parallel and none of them are perpendicular. So we take a look at that and we say, wait a minute, there's something that's perpendicular. If we took a look at this guy right here, 3/2, and this guy here, negative 2/3, that's opposite reciprocal. So we can say that xy right here and wx, so wx is the top line, and xy is the side, we can say that that's a square. So those two are perpendicular. And can we say anything else about any others? No, we cannot. So none of the other lines are perpendicular or parallel. Well, we haven't finished, yep, and that is, what is zy? Zy is minus 4/5, so there you are. So we are not perpendicular or parallel anywhere, but we have one perpendicular, but that doesn't get us anything. So we basically have a four-sided figure with no parallel sides. And if it has no parallel sides and no parallel or no angles that are the same and no perpendicular except for one corner, this is just a quadrilateral. Look at C. E is negative 1, 5, right there. F is 5, 5, right there. G is 3, 3. Right there, and negative 3, 3 for H. Now if we draw these lines, we can see right away that the top and bottom lines both have a slope of 0, so they're parallel. So now we just have to figure out the slope of EH. Well, its rise is 2, and its run is 2. So 2 over 2 is a slope of 1. So we're going to put a 1 there. And let's look at the rise for G to F, 2. The run is 2. So F and G, the segment F and G also has a slope of 1. We put a 1 there. So we now know we have two different parallel sides. This side here has a slope of 1, and this side here is a slope of 1, so they're parallel. This has a slope of 0 and a slope of 0 on the top, so they're parallel. So we know we have a parallelogram and a quadrilateral. The sides aren't the same, so it can't be a rhombus. There's no square perpendicularness, so it can't be a rectangle or a square, so it's just the parallelogram and then the quadrilateral. And lastly, we got W is 0, 3. Right there is W. Then 5, 2 is right there for x. Then 0, negative 3 right there for y. And finally, negative 3, 0. Negative 3, 0 for z. And if we connect these guys, oops, we see that we kind of have a lopsided figure. So let's look at our slopes. Let's try wx. Rise over run. I'm going to do it all in. Our rise is 1. Our run is 1, 2, 3, 4, 5. So this guy is 5 over 1, or 5. That's the slope of this guy. Let's see if this guy's parallel. The rise is 1, 2, 3. The run is 1, 2, 3, but it's negative 3. Negative 3 over 3, or negative 1 for the slope on this guy. So they're not parallel. Let's try yz, this guy here. The rise is 1, 2, 3, 4, 5. And the run is 1, 2, 3, 4, 5. So that is a slope of 1. And then we have a rise of 1, 2, 3, and 1, 2, 3. So we have a rise of 1 on this guy also. So what do we have? We have two parallel lines. Slope of 1 and a slope of 1 means that this line is parallel to this line. These slopes are different, so they're not parallel. And I'm going to do purple here and say that 1 times negative 1 is negative 1, so we know that this is a right angle here. And we can do it again in purple. This 1 times this same negative 1 means that this is a right angle. So what do we have? We have a four-sided figure with exactly one parallel set of sides. That is a trapezoid, and obviously a quadrilateral. And that's it for this lesson. So those are the things you have to do. Good luck.